of them unique. So let's get started. Now, as a general overview, we have the crust, which is the area that we walk on. We have the mantle, which represents the largest, thickest layer that is mostly made of rock. And then we have the core that's actually going to be broken down into two parts, and that's found deep inside the earth, and it's made mostly of iron and nickel. So we know most of our information, and the information that I'm going to share with you, we found out through the use of seismic waves and through the use of earthquakes. Now, I'm going to go ahead and share a few early tidbits about each one of those layers as they break down. And we have 4 of them that I'm going to talk about now, and then I'm going to go into more specifics further along in the presentation. Now, you have the crust, which can vary anywhere between 3 to 43 miles in thickness, depending on where on Earth you are. And it can get up to temperatures of 1,600 degrees Fahrenheit, which is still pretty hot. But it does get hotter as we go inward. So next, after the crust, you have the mantle. And the mantle is about 1,790 miles thick, and it reaches 8,000 degrees Fahrenheit. Now, after the mantle, as you go more inward, you approach the outer core. The outer core is approximately 1,410 miles thick, and it reaches temperatures of 11,000 degrees Fahrenheit. And finally, in the complete center of the Earth, you have what's called the inner core, and that's about 750 miles thick and can reach temperatures of 13,000 degrees Fahrenheit. So that's pretty hot. So let's get into this depth, or how deep these layers are. So between the 4 layers, to recap off what I just said something about, the crust is about 3 to 43 miles deep. So in one region, it might be 3 miles. In another region, it might go up to 43 miles, or it might fall somewhere in between there along the way. Moving along, you have the mantle, which ranges 1,790 miles thick. After that, you have the outer core, which is about 1,410 miles deep. And finally, the inner core, which is, again, 750 miles deep. Now, the main thing to get from these thickness and layers is to understand probably the extreme conditions between these layers. Now, first, I want to explore the thinnest layer, which obviously should stand out as the crust. That is between 3 and 43 miles deep. And after that, you have the largest or thickest layer, which is represented by the mantle. And that takes up about 1,790 miles of space. So it's the largest, and rightly so, according to the numbers. Now, I've told you about the deepness. I now want to go ahead and talk specifically about each layer and properties that make each layer unique. So we're going to start at the top, at the crust. And the crust is actually made of 2 layers, or 2 parts, if you will. Now, the top layer is mostly made of light-colored granite rock, and this is associated closely with the continental crust. As you can see in the image, it kind of has a light gray texture to it. Now, moving downward, you have the bottom layer. And this is mostly dark-colored basalt rock. And this is much more dense, and it takes a dark color. So looking at the image, you can see the oceanic crust kind of has a dark consistency that relates to the basalt rock. Now, this area is mainly made of silicon and oxygen, and that's what makes the crust and the next section we talk about kind of unique, because the crust is mostly made of silicon and oxygen. They actually can combine to form something called silicates that probably comes out whenever you discussed rocks or the unit about rocks and minerals. So, moving on, let's talk about the mantle. And the mantle is pretty cool. It's pretty thick, and it has a lot of things that makes it unique. Now, as I mentioned, whenever you're talking about rocks or minerals, you're going to hear about the word silicates. And so the mantle is mostly made of silicate rocks, and these are rich in magnesium, and they have more iron than the crust. Now, in addition to this, the mantle is, of course, the thickest layer, and it contains part of the lithosphere. And we'll talk more about that, as well as this next layer, which is called the asthenosphere. And it produces something unique called convection currents that heat the crust. Now, convection currents are used to actually heat the surface of the crust because the heat that emanates or comes from the core, which is much hotter, is carried upward towards the crust, which is much cooler, and then once cooled, it goes back down, and it kind of creates kind of a spin cycle. That's why it's called the convection current. The convection current works similar to kind of your conventional oven, and the heat rises, cools down, comes back down. Now, the mantle possesses the convection currents that are responsible for heating the crust. This heat is carried up from the core. It circles, emanates, and comes back down once it's cooled down. And we're going to show you an example video where you have a heat source working like a current, where you have kind of a hot source of water and a cool source of water. And without further ado, they're dyed with blue and red just to give you perspective as to how they look. So looking at this image, there's a tank of water. Hot water and cold water are added. And notice the red water goes to the top. It begins cooling. The blue water, which is the cold water, goes down to the bottom, and it creates kind of a spin cycle fashion. Now, this is a perfect depiction of how convection currents work in the mantle, because you have the water that is hot, starting off hot, cooling down, going down, cool water, which is cold, coming down, and then rising. So, getting back down to the presentation, we now have the outer layer. And the outer layer is mostly made of iron and nickel. It is also made up of a superheated liquid molten lava, which makes it unique from any of the other layers. And it is responsible for the Earth's magnetic field. So if you have a compass, you can thank your lucky stars that you have an outer layer in Earth's planetary layers. So moving on, we finally have the inner core. Now, the inner core is perhaps the hottest layer. It is believed to be almost as hot as the sun, if not hot as the sun. It is also the most dense layer. Pressure builds up in this area the most, and it is because of this pressure that, unlike the outer core, which liquefies, the inner core does not liquefy because of so much pressure. And finally, this solid ball, mostly made of iron and nickel. So, now we're going to talk briefly about the lithosphere and asthenosphere, which I briefly mentioned previously. Now first, the lithosphere is made of the crust and part of the upper mantle. And this can be seen in the image to the right. Now this area is represented by hard rock, usually continental crust and oceanic crust. So it has kind of a solid consistency. This is where your more solid tectonic plates or landmass that you think of when you think of walking on hard stuff. That's your lithosphere. The word lithos actually translates to, in Greek, to mean rock. So, in addition to this rock area underneath the lithosphere, we have a plastic layer known as the asthenosphere. Now, the asthenosphere is found in the upper mantle and underneath the lithosphere. It also facilitates the movement of tectonic plates. However, that will be saved for another discussion. Now, that covers the layers, and I've talked about the lithosphere and the asthenosphere, but I also want to talk about how these compositions break down just from a standpoint of looking at the layers as a whole. So first I want to start with kind of an image that shows the composition of Earth's components, what it's made of, the elements. And so here you have, as I mentioned, in the external portion of the Earth, you have the granite rock, which is lighter in color, and then you have the basalt rock that's kind of mixed in there. And moving inward, you have iron, and then you have an increase in nickel. And so you have all of these elements that contribute to the composition of Earth. Now, looking at the Earth from a standpoint of temperature, as you move downward from the crust down to the core, the temperature begins to get hotter. The crust is notorious for being cooler than the mantle and the core is notorious for being the most hot layer. And then finally, looking at the density of Earth's layers, the core is the most dense, and the crust is the least dense of all the layers. And so those properties are the things that you want to be able to understand when talking about Earth's planetary layers. Once again, the four layers are crust, the mantle, the outer core, inner core, each of which have their own unique properties. And hopefully today you have now learned those four different layers.